You were asking was concentration versus
Yes, zero order and first order complete.
the concentration versus time का in reversible and irreversible वाला concept.
Yes,
the
yes,
last
only
question.
basic part is complete. Yes. Yeah, next move on. Chemical kinetics. Yes, do you have any whiteboard? Yes, go through on whiteboard, then discuss.
अच्छा, whiteboard sir, there is whiteboard.
Yes.
Okay. Sir, in BARC also they will provide us whiteboard. We have to discuss everything on whiteboard.
Yes, yes, on whiteboard, yes.
Okay, sir. Sir, actually, I'm having phone, so I'm talking to you as on. Is that comfortable? I'm talking to you on phone.
Yes, no problem. Yeah, let me start. Topic name is chemical kinetics. Yes, what the difference
Yes.
between order of reaction and molecularity? Explain.
Sir, if you consider, sir, the reaction, uh, sir, if you consider the reaction, for example, A plus B giving C plus D.
Yes, yes.
Suppose the rate is equal to K A to the power 1, B to the power 1. So if you take the order of the reaction, it will come out to be 1 plus 1, and which is 2. If the order of the reaction comes out to be 2, and the molecules that are getting participated are also 2, then we usually say it is a molecularity. But when we consider order of a reaction, it is experimental basis. So order of the reaction can be or cannot be equal to 2, 4.
Yes.
So order of the reaction can be 0, 1, 2, 3, or fractional also. So molecularity is just a subset of the order. So order is experimentally based, and molecularity is just the number of molecules.
Yes.
That's the basic difference between the both.
Yes, good. The next move on. Zero order reaction. First of all, basic. What the main application of zero order of reaction?
Yes. A is equal to B, rate is equal to A. So for example, the reaction A goes to B, rate is equal to K, A to the power 0, rate is equal to K. So rate of the reaction would be equal to the rate constant. And the unit of rate constant would be so the application of first zero order reaction you're talking about.
Yes, zero order reaction. Yes, main application. What is zero order reaction?
A zero order reaction is, sir, when the rate is equal to the rate constant, and when we plot the graph would be equal to like this only. So rate, the slope would be equal to the rate constant and versus time. So the value is this, and A is equal to A naught minus KT. This is the basic equation of zero order reaction. A is equal to A naught minus KT. So this is the basic. So do we have to derive it also, sir?
Yes, derivation
How
of
this equation comes?
Yes, derivation of zero order reaction, and also graph of zero order reaction, rate versus concentration, and concentration versus time.
Okay, sir.
Yes, explain.
Yes, sir. Deriving it, sir. So deriving on white. Sir, what are the graph that you were asking about? Rate versus
Rate versus concentration and concentration versus time.
concentration versus time. Concentration of reactants or concentration of products or both.
Yes.
ठीक. A is equal to A naught minus KT. So I have derived it. So minus dA, for example, if you take reactant A which goes to B, are you able to see? So
Yes.
minus dA upon dt is equal to minus K A to the power 0. A to the power 0 would equal to be 1. So if you take using integration A naught to A and 0 to T, so after doing integration, it will come out to be A minus A naught is equal to minus KT, and A is equal to A naught minus KT. If you take graph also, if you plot this thing into graph, concentration versus time, so the slope would be equal to minus K, and A naught, the intercept would be equal to A naught, and this is the concentration. This is the basically the graph. And if you take is equal to rate is equal to T, rate versus time, the slope would be is equal to K. That is a very linear line. So these are two graphs that I have plotted.
Which graph is? Graph.
Yes, sir. Graph this. Are you able to see, sir?
Yes, this one is a concentration versus time. Yes, no. Upside is a rate
Yes, sir.
versus. Yes, right.
Upside is rate versus time.
Yes. Is what the zero order half-life of zero order of reaction? First of all, what is half-life? And next question is, what is the half-life of zero order reaction?
Okay. So the half-life is basically is the time at which the concentration is equal to half of the initial concentration that we took at the beginning of the reaction. That is basically T half. For example, at T half is equal to at T half is equal to A is equal to A naught by 2. So if we put this thing A naught by 2 is equal to A naught minus KT. So T half comes out to be A naught by 2. Okay. The T for zero order reaction, T half is equal to A naught by 2K. If we take at T half, A is equal to A naught by 2. And if we put this thing into this equation, A is equal to A naught minus KT, T half comes out to be A naught by 2K for zero order reaction.
Yes, good. Any limitation of zero order reaction? Drawback, limitation?
Limitation, sir. Limitations are if we study about rate of the reaction versus time. So it is usually non-dependent on the concentration. So I think that this is the only limitation that has. This is one of the limitations that it has.
Yes, good. Next, move on. And what the example of zero order of reaction? Example of zero order of reaction.
Sorry, sir, I am not able to recall, sir, an example.
Yes, Haber process. Any catalyst, mostly
Haber
catalyst reaction presents in catalyst which called is zero order of reaction.
Sir, what is your question, sir? Can you repeat, sir? What is?
Mostly catalyst reaction is called zero order of reaction.
Okay, sir. Okay. Mostly
Haber process.
catalysis.
Haber process
Okay, sir.
example. Haber process N2 plus 3H2 2NH3. Presence of iron and
Yes, sir.
molecule. Yes.
Okay, sir. Okay.
Next, move on. First order of reaction. What is first order of reaction?
Okay, sir.
The main application of first order of reaction.
So basically, when you take, for example, A goes to B, rate is equal to K A to the power 1. When the order of the reaction is 1, it is usually uh, called as first order reaction. And mostly, sir, it is application when we talk about all the major radioactive decay, for example, uh, radioactive decay that we talk about, uranium and all other, they all mostly they prefer zero first order reaction, radioactive decay that we call about.
Yes.
A is equal to, on solving
Yes. What the derivation of first order of reaction?
the derivation is when we sir, I have proven rate is equal to uh, are you able to see, sir?
Yes.
A is equal to A naught e to power minus kt, e to the power minus kt that we have derived. If we take minus dA by dt is equal to Ka, and the A would go into the denominator and T dt will come this side. From 0 to T and A naught to A, if we solve it, the integration would come out to be ln A, natural log A to the power A net. From on solving this, we get A is equal to A naught e to the power minus kt.
Yes. What the slope and graph of rate versus time, concentration versus time? Can you draw on board?
Yes. So A is equal to A naught minus kt. This is A versus time, and the intercept will be A naught. So it will give this thing kind of curve.
Yes. Yes. Rate versus time. Yes.
Yes, sir.
And concentration versus
And sir,
time.
so the concentration versus time, I'm not able to, with confidence, I would say that I was a bit, rate is equal to Ka, which slope is this correct, sir? Is this correct that I have drawn
Yes. Yes.
this one?
Correct. This was wrong. Yes.
This one?
Yes. Concentration versus
Oh,
time. No?
yes, sir. the graph of concentration versus time would be equal to, would be somewhat, it would be, if we take, how to put this into graphical form? Do we have to take log of both sides? Log rate is equal to log k plus log a.
Yes. Log versus time is different graph. Yes. Can you draw also?
That one is different. Oh, that
Yes.
one is different. Log rate is equal to log k plus log a. Log rate. Log rate versus time you are asking about, sir.
This other graph is log versus time. Len versus log versus time. Yes, you have derived the final product of first order of
Yes, sir.
reaction.
Yes, sir. Yes, sir. Log a no minus k. Minus k upon 2 point. It will be the slope. So the graph is like this one.
Yes. Right.
Slope would be minus k by 2.303.
Yes, right. What the relation between first order of reaction and radioactive decay? What the relation?
Sir, if you allow me, I could give a calculated guess. It would be a concentration at time t is equal to a naught upon may 2 to the power n. N is equal to the number of years. A naught by 2 to the power n.
Yes. And what the half-life of first order of reaction?
Sir, it is equal to 0.693 upon may k. That is slope. T half.
Yes, good. What the drawback, any limitation of first order of reaction?
So the drawback is, sir, generally the first order reaction generally don't go to completion. So I think it is one of the drawback of first order reaction.
Yes, what the example of reaction is first order of reaction?
So first order reaction example, sir, if you take for example carbon 13, that isotope it usually take. If we study the disintegration, it may follow the first order reaction. If you take uranium 235, if you study the radioactive decay, so it may also follow the first order reaction.
Yeah, decomposition of N2O5, decomposition of SO2Cl2. Yes. SN1 reaction is also first order of
Okay.
reaction.
Yes, sir.
Yeah, next, go through on second order of reaction. What is the main application of second order of reaction? What is second order of reaction in chemical kinetics?
Yes, sir. Sir, for a zero order reaction, rate is equal to K 8 to the power 2. So order of the reaction is 2, for example, and when we derive it, sir, minus dA by dt is equal to K a to the power 2, and it will go to denominator. dt will come this side, and on the basis of integration, we take a naught will go to a, and time time will go from 0 to 2, and on solving this, it will come out to be 1 by a is equal to 1 by a naught plus kt for a second order reaction. On solving this, it comes out to be for a second order reaction.
Yes, what the graph and slope of rate of versus time, concentration versus time in second order of reaction?
Sir, I have plotted this thing, the concentration versus time 1 by a naught versus time 1 by a naught would be the intercept, and plus k would be the slope of the reaction. This is the concentration versus time.
Yes. Concentration versus
Sir,
time.
for yes, sir.
Rate versus time.
For rate versus time, sir, I'm not able to, sir, recall correctly how to plot this graph, how to plot versus rate versus time. So because rate is equal to k to the power 2. So if you plot it, sir, I'm not able to recall, sir.
Okay,
I'm
no
having a
problem.
difficulty in rate versus time in first order also,
Mhm.
second order.
Yes, what is the half-life of second order of reaction?
The half-life of the reaction is 1 by a naught k. 1 by a naught into k. 1 over.
Yes, what the example of reaction is second order of reaction?
So I would say the formation of ester is an example of a second order reaction.
Yes, SN2 reactions.
Okay, sir. SN2.
Yes, any drawback and limitation of second order of reaction?
Sorry, sir, I cannot tell any limitation as such. No.
Okay, no problem. Yes, I sent already in a limitation in group. Yes, you check topic wise, one by thermokinetic, coordination, electro. Yes.
Yes, sir. On WhatsApp group, sir, I was checking, sir. You have
Yes.
shared various
Yes, I
things on
shared all
thermo also.
topics, question and limitations.
Yes, sir.
Next
That
move
was I
on.
was checking, sir. First or
Yes, yes, sure. Next move on third order of reaction. What the main application of third order of reaction? What the derivation of third order of reaction? Explain one by one point.
third order reaction, right, sir?
Yes.
Sir, I have derived the equation for third order reaction. Minus dA by dt is equal to K a to the power 3. A to the power 3 signifies the order of the reaction is 3. And on solving this thing, minus dA by 8 to the power 3 is equal to K dt. On solving the integration from a0 to a and 0 to 2, the equation comes out to be 1 by a square is equal to 1 by a0 square plus 2kt.
Yes. Good. What the graph of third order of reaction? Rate versus concentration, concentration versus time.
So the concentration versus time would be this graph with the slope of 1 plus 2k, and 1 by a naught square would be the intercept. This is the concentration versus time graph. And
Yes.
the rate versus time, sir, I'm having difficulty, sir, how to
Rate
make
versus
that graph.
concentration. Rate versus concentration.
Rate versus concentration.
Yes.
Sir, if the question rate
Okay,
versus
no problem.
concentration.
If you look them, yeah, you have to study about it.
Mm-hmm.
Next, what the half-life of third order of reaction? Any half-life?
Yes, sir.
Half-life of third order of reaction.
Yes, sir, deriving it. So the T half would be 3 by 2 k a naught square. will be the T half for third order reaction.
Yes, good. Any reaction of third order of reaction? Any types of reaction, third order of reaction?
Types of third order reaction. I'm not able to read.
2NO plus
Third order
O2.
reaction.
2NO plus O2, 2NO2, 2NO plus Cl2, 2NOCl.
Okay.
Any limitation drawback of third order of reaction?
Sir, for third order reaction, for example, molecularity is 3, for example. So it would be very difficult to study like 3 molecules reacting simultaneously and colliding, and it lead to the formation of products. So it would be very difficult to study this type of reaction.
Yes. Yes, next move on. Next new topic is activation energy. Yes, what the main application of activation energy in chemical kinetics?
Sir, main application is like, sir, activation energy is the energy, minimum energy that is required by the reactants to form products. For example, the energy, for example, if for a reaction, the energy, activation energy is 10 kilojoule. But if you have provided the energy, for example, 5 kilojoule, so it won't be able to provide the reactions. But if you, the moment you provide 10 kilojoules, it will make into it, the reactants would be easily got converted into products. So this is the basic fundamental reasoning behind the activation energy.
Yes. What the difference between threshold energy, activation energy, actual energy? What the difference?
So for example, if you take a graph, sir, let me show you with the help of graphs. Are you able to see it, sir? Graph potential energy versus reaction coordinate. It is an exothermic reaction. If we plot this thing, this is energy of the activation energy. It is EAF. It signifies the moment you provide this kind of energy, it will form into products, and it is delta H, which is equal to EAF by minus EAP delta H. But if you take the whole energy, that is EAF and delta H, it will form the threshold energy.
Yes. What the difference between exothermic and endothermic reaction in activation?
Yes, sir. Sir, in exothermic reaction, EAF.
Yes, good.
So the exothermic reaction is this, and the endothermic reaction is this.
Yes, yes.
Graphically.
Yes, yes, good. Yeah, next day we will discuss on the left part of chemical kinetics. Yes, Arrhenius, collision theory, activation, Lindman. Yes, so many parts. Today is good
Sir.
work from your side. Yes. And limitation I
Okay, sir.
send on WhatsApp group. You will check. Yes.
Okay, sir.